This is the first video on multiplying polynomials. And to start with, let's start with some vocabulary. So first of all, nomial just means name in Greek. So what a monomial means literally is one name or one term. So an example of a monomial is 3x to the fifth, or 2x squared y to the third, or even just the number 5. So a monomial is simply a polynomial that has a single term in it. And to see that, let's contrast that with a binomial. Bi means two, as in bicycle, right? Two wheels. So binomial means two names or two terms. An example would be 3x squared plus 5. So when we're talking about polynomials, we talk about an expression and a term. A term is separated by plus and minus signs. Here's another example. 5x minus 3 has two terms, as does minus 4x squared plus 18. So we want to contrast that with a monomial. It's not that there's a minus sign or a plus sign. For example, in a monomial, if it was minus 3x squared, it would still be a monomial because it's still a single term. Binomial has two terms connected with a plus or minus sign. Once we know what a monomial and a binomial is, a trinomial is pretty straightforward. It simply has three terms. An example would be 2x squared plus 6x minus 10. Another example, minus 3x to the fourth y squared plus 2x squared y minus 3. A polynomial simply is a nomial with any terms, right? So a polynomial can include monomials, binomials, trinomials, quadrinomials, however many terms it is. So a polynomial is simply, as an example, it could be any of these. Minus 3x to the fifth is a polynomial, 3x squared plus 5 is a polynomial, 2x squared plus 6x minus 10 is a polynomial. Even if it had four terms, 4x to the fifth plus 2x squared y plus 3y minus 7, four terms, it's also a polynomial. So if you think about what we're going to do in this lecture, we're going to do the following multiplications, right? This we're talking about multiplying polynomials. Monomial times monomial, monomial times polynomial, which is really just distributing. Binomial times binomial, and binomial times trinomial. Binomial times binomial, we just know is FOIL. Actually, rather than looking at all these terms, let's just look at an example of each. The first example we're going to look at, 5x squared times 10x to the fourth, y to the third. The second example we're going to look at, 4x squared, 3x minus 5. The third, x plus 7, 2x plus 3. And the last example, x minus 7, 3x squared minus 5x plus 2. If you look at these are just examples of each one. Here you have two monomials. Here you have a monomial and a polynomial. Here you have two binomials. And here you have a binomial times a trinomial. So let's just look at each one of those examples in turn. In this case, if you're multiplying a monomial times a monomial, the rules are real simple. Simply multiply the number times the number. That's 5 times 10. That's 50. Then multiply x squared times x to the fourth. X squared times x to the fourth is going to be x to the sixth. Remember, when you're multiplying terms with powers, you add the exponents, and then there's a y here but not a y here, so there's simply y to the third. If you want to look at another example, let's look at minus 2x to the fourth times 3x to the third. Minus 2 times 3 is a minus 6. x4 times x3 would be x to the seventh. Just another example. That's monomial times monomial. Let's look at the next one, which is a monomial times a binomial. That's just distributing, right? When you have a parentheses and you have something outside like this, 4x squared, 3x minus 5, then all we're going to do is we're going to simply distribute into the parentheses. So that's 4x squared times 3x, that's 12x to the third, and then 4x squared times minus 5, a positive times a negative becomes a negative, and it's just minus 20x squared. If you want to look at another example, let's look at minus 6x squared, 4x minus 10. You just distribute across. And then you go minus 24 x to the third plus 60x squared. In both these examples, we had a monomial times a binomial. It would be exactly the same if you had a trinomial. It's just that instead of distributing once, you distribute 3 times. That's minus 2x squared. That's going to be a minus 2x to the third. Minus 2 times a positive 6 is a minus 12. X times x squared is x to the third. Minus 2 times 10 would be a positive 20x. The next example that we have is a binomial times a binomial, or the problem that we're working with here was x plus 7 times 2x plus 3. This is, we're going to use a method called FOIL, first, outside, inside, last. If you have a question on this, there's a video, and the video is called FOIL. So if you need some further examples on that. And here we simply go x plus 7, 2x plus 3. You go first times first, that's what the F is for. And then after you do that's x times 2x, that's 2x squared. Then you have O. O stands for outer, first outer. That's x times 3, that's a positive 3x. Then you have inner, which is the I, that's 7 times 2x, that's 14x. And last, you have last. First, outer, inner, last. That's 7 times 3, which is positive 21. At this point, you need to combine like terms. If you combine like terms, if you notice you have a 3x and a 14x, that becomes a 17x. So your final answer is 2x squared plus 17x plus 21. And that's your answer. Let's do one more example of that. Let's do 3x minus 5, 2x plus 3. Remember, F-O-I-L. First times first, that's 3x times 2x, that's 6x squared. Then you have outer, 3x times 3, that's going to be a 9x. Then you have inner, minus 5 times 2 is a minus 10x. And then you have last, minus 5 times 3 is a minus 15. Then you combine like terms. Here you have a minus 10x and a positive 9x. That becomes a minus x. The last time is when we have a binomial times, in this case, a trinomial. And let's look at that example. X minus 7, 3x squared minus 5x plus 2. Though this looks a lot like a FOIL problem, a better way to think about this is actually a distributing. What we're going to do is we have 3 terms here. We're going to distribute the x minus 7. So first thing we're going to do is distribute the x. So we're going to take the x and multiply by every single term inside the parentheses. And then after we do that, we're going to take the minus 7 and do the same thing. And I'm going to arrange my answers in a certain way. You don't have to do it that way, but it helps a little bit keeping everything straight. X times 3x squared will be a 3x to the third. And then x times a minus 5x is a minus 5x squared. And then x times 2 is a plus 2x. So first I distribute the x across the three terms. Then I distribute the minus 7. So it's minus 7 times 3x squared, which is a minus 21x squared. I'm going to stack that below the x squared. That's minus 21x squared. And then it's minus 7 times a minus 5x. That's a positive 35x, and I'm going to stack that under the x there. And then the last step would be minus 7 times 2, which is a minus 14. And now I'm going to combine like terms. So it just so happens that because of the way I've stacked it, that these are going to be like terms and these are going to be like terms, just because of the way that I happen to do it. So my final answer is 3x to the third minus 26x squared plus 37x minus 14. And that's my final answer right there. Let's do one more example of multiplying polynomials. Let's say we had 2x plus 4, 3x squared minus 10x minus 6. This is about as hard as these ever get. First thing I'm going to do is I'm going to take the 2x and distribute it. And I'm going to get 6x to the third, right? 2x times 3x squared is 6x to the third. That's the reason I wrote a 3 there. And then 2x times minus 10x is a minus 20x squared. 2x times minus 6 is a minus 12x. Now I'm going to distribute the 4 across the three terms. That's going to be 4 times 3x squared is 12x squared. 4 times a negative 10x is a minus 40x. And 4 times minus 6 is a minus 24. Then I'm going to simply combine like terms. If you notice, this is an x squared and that's an x squared. This is an x and this is an x. My final answer is going to be 6x to the third minus 8x squared minus 52x minus 24. And I'm going to put a purple box around that. And that's how you multiply polynomials.